All right, today for Algebra 1, we are doing lesson 5.6, which is direct and inverse variations. All right, so our objectives are to find the constant of variation. Okay, so we're going to look for that constant of variation for direct and inverse variations. Sorry, I keep wanting to say direct and indirect. Objective 2, we're going to identify relations that are direct or inverse variations. We're going to write and apply function rules for direct and inverse variations. And 4, we're going to solve real-world problems modeled by direct and inverse variations. So first of all, the definition, a direct variation, which is the variable k. Okay, we're going to use the variable k for it always, is a function in which the ratio of variables is a non-zero constant, k. Okay, so it's always going to be a constant. The ratio of variables is. So that is y divided by x equals k, okay, where x is not 0. So in this case, a direct variation, the quantities are said to vary directly or be directly proportional. We've studied proportions already, so that's going to be helpful. K is your constant of variation, okay, or your constant of proportionality. That is it. K is the name of the variable. Slope is m. The constant of variation is k. So we can state these functions, okay, as y equals k times x, or we can write it as a function instead of a y. So f of x equals y times x. All right, and one more thing about direct variations is an increase in one variable causes an increase in the other variable. Okay, so an increase in one causes an increase in the other. Always, always, always. Okay, so then let's look at example 1. Does the table represent a direct variation? If so, find the constant of variation and write the function rule. All right, so first of all, so we've got our table over here, x and our y, and we have our x values are 1, 2, 3, 4. Our y values are 7, 14, 21, and 28. So to answer the question, does the table represent a direct variation? We can simply use that ratio, like does this work out? Let's use it. So if we do 7, so if we try this, we're going to do 7 is our y divided by our x, 1, equals k. Okay, so 7 divided by 1 is 7. So our k value here is 7. So let's try the next one. We have 14 divided by 2 would equal k. 14 divided by 2 is 7. Hey, this is looking like it's a direct variation. Let's try it with the next one. 21 divided by 3 equals our k value. 21 divided by 3 is indeed 7. And the last one, 28 divided by 4 will equal k. 28 divided by 4 is 7. So this works, okay? So yes, it is a direct variation. Okay, I didn't give us much room here for my work. So let me write it over here. Yes, direct variation. Okay, so we answered that question. If so, it says find the constant of variation. So we found that repeatedly, right? K equals 7. And it says write the function rule. These are really easy to write. Remember, when we know the function rule, how do we get from x to y? We multiply by 7 every time. So our function rule here is going to be f of x equals 7x. So f of x equals 7x. Okay, and I want to go back here. I noticed this earlier and I kept talking. Let's go back to this equation up here where I have f of x equals y times x. There should be a k I noticed it like after I set it and started solving, but didn't go back. So it should be f of x equals k times x. Which, mind you, is exactly what we used here. Right? To write our function rule, we took f of x and it equaled the k value times x. You could have written it the other way as well and had y equals 7x. Both of those are correct function rules. It's just, do we use function notation or the y equals notation? All right, let's keep going. Okay, example 2 says find the constant of variation if y varies directly with x and y equals 6 and x equals 3. Write the function rule for the variation. All right, so we want to find the constant of variation. All right, we know that y equals 6, so we need to plug that in. So we're going to have k equals 6 over our x is 3. So k equals 6 divided by 3 is 2. Okay, and so now we want to write the function rule. Okay, to write the function rule, remember it's going to be f of x equals k times x. So f of x equals, our k value is 2, so it's going to equal 2 times x. And there you have it. Pretty quick stuff there. All right, let's look at this note here. When two quantities vary directly, okay, so when they vary directly, their ratio is constant. Remember, their ratio is a fraction. So for two different ordered pairs, x sub 1 and y sub 1, and x sub 2, y sub 2, they have, if we set them up as a ratio, right, as a fraction, they both equal k, because they have a direct, they vary directly. Which means, this is the cool part, we could set up the proportion and say, well, y1 over x1 equals y2 over x2. This is true for any direct variation, any of them at all, that we can use this because it's direct and they both have the same constant of variation because they're varying constantly, the same way every time. Okay, on the back side then, example 3. If the distance traveled varies directly, again, these are key words, varies directly with time, and Jose rode 12 miles in 45 minutes, how far can he ride in 2 hours? All right, so I gave you a hint here. So the hint says use a proportion, or you can find the constant of variation. So we can look at it two different ways. All right, so for the first way, if we use this proportion, so if the distance traveled varies directly with time, and Jose rode 12 miles in 45 minutes, how far can he ride in 2 hours? So we want to know how far in 2 hours. So if we do distance, we're using this proportion of distance over time. So he traveled 12 miles in 45 minutes. And that's equal to how far, well, that's a question mark. So that would be like our x here, or a d, actually, let's make it d. That would be better since we're talking about distance. So that's going to be d over, our time in this case is 2 hours. All right, it's problematic that our units are not the same here. We have minutes and hours. So we need to make those the same in order to be able to use them. So if we want to change hours to minutes, 2 hours is how many minutes? Perfect, 120. Oh, got to get rid of my eraser for us to make progress here. All right, so we're going to have our distance over 120 minutes. Now that they're the same, we can solve. So remember, we cross, So we're going to have 12 times 120 equals 45D. We would divide by 45 and get 32 miles equals distance 2. I should have put that in there. So they can go 32 miles in 2 hours. Now, the other way you could solve it is to find the constant of variation. So doing this distance over the rate is what I have there, or the distance over, or sorry, it should be the time, not so much the rate. Yeah, that should be a t. Okay, a couple mistakes today. I don't know what's going on. Must have been distracted when I was doing my notes. All right, so if we do the distance again, so 12 over 45, and that equals k. All right, so what would k equal? So 12 divided by 45. Now the problem with this one is it's going to give you an ugly decimal number, so 0.26666 repeating, unless you can get it to a fraction, which would be 4/15 equals k, which you can do, but it's not super helpful. But if you go back to that idea, right, then and you write your equation, so the distance is going to equal the time times your constant, then distance is going to equal 4/15 times, or well, our time is 120. So let me change the order here. So it should be 120 times 4/15 to get them in the right order. And then you would get d equals 32 miles because it's distance. All right, so you could choose whichever one to do, but the proportion is something we're already familiar with, and it should be helpful for you to use that one. And then you're not stuck with an ugly decimal to use or a fraction to use. All right, let's look at the next one. We have this awesome table here. Notice it says base and height, B and H. It says, does this table of base and height measurements of rectangles represent a direct variation? So again, we're trying to find that constant. So if we took okay, so think about k equals our y over our x's. So in this case, it's going to equal the height divided by the base. So if I take 12 and divide by 1, it equals 12. If I do 6 and divide by 2, well, that equals 3. Time out. 4 divided by 3 equals 4/3. So does this table of height and measurements of rectangles represent a direct variation? No, absolutely not, it doesn't. Okay, but do you notice anything about this table? If you don't, that's okay. We won't worry about it right now. But it is not a direct variation because their k value is not constant, right? Because the k equals 12, the k equals 3, it equals 4/3. It's going to keep changing. Okay, this is an inverse variation. I need to move it up a little bit. So let's go ahead and clear these notes so I can move it up and talk about the inverse variation. So this is an inverse variation. It's not a direct variation, it's an inverse variation. And this is when it's a relation in which the product, okay, remember product means to multiply, of the two variables is a non-zero constant, k. So this is when it's a product. So when we take x and we multiply it by y, and it gets us the k value. Okay, and k cannot equal 0. So these quantities vary inversely. which means, look down here at the last part, an increase in one variable causes a decrease in the other variable. That's what vary inversely means. So these two are connected. So check this out. Since the base and the height is an inverse variation, it's saying that x times y equals our k. So in this case, we're going to have 1 times 12 equals k. So 12 equals the k. In the next one, 2 times 6 equals k. So we have 12. The next one, 3 times 4 equals k. All right, so then we have 12 equals k. Hey, this is proof that it's an inverse variation, because if I multiply the x and the y, then that's when I get a constant for my k value. Not when I divide them, but when I multiply them. So k is still the constant of variation. It's just set up differently. It can also be stated as y equals k divided by x, or f of x equals k divided by x. So if I was writing a rule for this one, okay, up here that we did the example for, I would have f of x equals, my k is 12, so it's going to be 12 divided by x. Knowing this lesson today is going to help you write those rules a lot easier than when we started the other day. Okay, so let's look at example 4. Does the table represent a direct variation, an inverse variation, or neither? If it's a variation, find the constant of variation and write the function rule for the variation. All right, so first up, is it a direct variation, an inverse variation, or neither? So we need to, if it's direct, we're going to do y divided by x equals that constant k. If it's inverse, it's x times y equals that constant k. So which one is this? Good, you can show some work and you can find out, or like you can look at it and see how these numbers are getting bigger every time. So I'm going to put a plus sign that they're getting bigger every time, where these numbers are getting smaller every time. So I'm going to put a minus sign. They're getting negative. That's the exact part of the inverse variation. That's the sign. Because an increase in one variable causes a decrease in the other variable. So x is increasing, y is decreasing. So it may be inverse. We need to check it, which means we need to take our x, 2, and multiply by our y, 72, to get our k. And that's 144. And then we need to take another one. We need to take our x4, multiply by our y, 36, to get our k, and that's 144. All right, so if you did this for all of them, then you would find that it is an inverse variation because all of your k's are 12. So woohoo, it's an inverse variation. So if it's a variation, find the constant of variation. We did that, k equals 144. And write the function rule. Okay, so just like up here, we're going to say f of x equals our k value, so 144, divided by the x value. Ta-da! There is our function. All right, then let's go to this last page. I guess I didn't get that cleared off. So when two quantities vary inversely, their product is constant. So we're just restating that. So for any two different ordered pairs, that x sub y, or x sub 1, y sub 1, and x sub 2, y sub 2, they're going to have, like when we multiply them together, x sub 1 times y sub 1, we get the constant k. And if we multiply x sub 2, y sub 2, we get the constant k. So we can set these products equal to each other. This equation can help you solve inverse variation problems. Proportions help you solve direct variation, and this one helps you solve inverse variation problems. So let's look at the example 5. The number of census workers varies inversely, okay, these are keywords, with the number of days it takes to complete the census in Pleasantburg. If it takes 24 workers 15 days to complete the census, how many workers, okay, so there's our question, how many workers, question mark, are needed to complete the census in 10 days? All right, so then I gave you a hint here. We've got W sub 1 equals, or times D sub 1 equals W sub 2 times D sub 2. Well, W is going to stand for the workers, and D is going to stand for the days. So we can take these pieces and put them in. We know in the first day, right, we had 24 workers and 15 days. And that has to equal how many workers in 10 days? Well, we don't know, so let's call it W times 10. But we do know how to solve this. And this is W sub 2. Let me put that in there. So we would divide by 10. And so 24 times 15 divided by 10, I'm assuming you have a calculator with you, is going to be 36. So 36 equals W2. Or we would say 36 workers in 10 days is what we need. Awesome. So just using those formulas to help us, to plug in and to help us solve them. But knowing the formula for inverse and variation and direct variation is going to be very, very helpful. So we have this nice summary chart here at the bottom. That's pretty much filled in for you, but we're going to fill in the last part together. Okay, so if you notice, we've got direct variation in the first column and inverse variation in the second column. And we have the definition, the constant, what that implies. So the function, or the equations that we can use to help us solve, the function rule, and a graph of what they each look like. All right, so in order to find the constant k for the direct variation, what do we do? Excellent. We take y divided by x, and that equals k. Remember, that's different, though, than the inverse. What do we do in the inverse? Excellent. We multiply them. So we have x times y equals our k value. Good. How about the function rule? What's the function rule for a direct variation? Good. We have y equals k times x. And what is it in our inverse variation? Good. It's division. So we have y equals k divided by x. Awesome. All right. Well, then that wraps it up for today. So you can get started on your homework, and I'll see you tomorrow. Make sure you also work on your study guide. Get it, like finish it up. Tomorrow we're going to have a review day, and come with questions. Like come with your study guide as much completed as possible, except for the problems that you have questions with, so we can work on them and talk about them as a class. All right. See you then.